Whoa. I think I just had a revelation. Like 10 seconds before I hit this record button, it hit me. I was putting together these slides and demos for this nugget. I'm like, this is going to be really cool. But I started getting like this unsettling, like, ugh feeling. And I'm like, what is that? And it just now hit me. I think I have a gripe with the cloud. It has completely eliminated my cool factor with friends and family. I used to go over their house and I'd be like, dude, check this out. I can set up a VPN connection from your computer to my house, and I do like this little SSL VPN and bring up remote desktop, and they're like, is that your computer? I'm like, yeah, it's my computer. And they're like, whoa, how do you do that? You're amazing. And I'm like, I know. It just kind of, I think I was born this way. Now I do that, and they're like, yeah, wow. Doesn't Dropbox kind of do that too? And I'm like, well, yeah, but for the files. But what about your app? Well, they're like, well, log me in, go to my PC. Have you heard of those things? I'm like, well, yeah, but I start finding myself, I'm like, I think a communist government owns that website. I mean, how does that make you feel? I mean, come on, what am I doing? I'm reaching for like scaring people so that they'll still think I'm cool. Anyway, this is going to be, I think maybe that was supposed to be just for me, but it's out there now. This nugget is going to be focused on how we can connect into AWS using a VPN connection, many different options. Here are your do I know this already questions. Pause the video, look them over. If you know them, you probably don't need to go through this material. Otherwise, let's get started. My kids are in the midst about learning this concept of homonyms, and so it seems like whenever I'm walking around the house, I'm hearing this language all the time. Oh, careful! Don't fall down. Oh, Daddy, that's a homonym. Well, you can do anything except Daddy, homonym. Don't worry, I had to ask my wife too. What was the homonym again? It's a word with a double meaning or more than one meaning, and when you come to VPNs, they are the ultimate technical homonyms. What most people think a VPN is, if you were to poll 40 out of 50 technical people and say, what's a VPN? They would say it is a user working remotely on some kind of device. Could be an iPad, it could be a laptop, a desktop, and they are connecting to corporate resources over a public network like the internet, and they encrypt their session. And some will even go as far as saying this is called an encrypted tunnel between the two. There's no physical tunnel. It's just that every single time the server sends data to you or you send data to the server, it scrambles it. That's what defines the VPN connection, so that prying eyes, they're not even looking the right way, prying eyes on the midst of the internet aren't able to catch and see your data. So most people will say that is a VPN, and they are accurate. That is one type of virtual private network known as a remote access VPN. Others would say, oh, well, actually, you could do that with another office too. I could take, my office in Arizona, connect it to an office in Atlanta, have my servers at both sites, and they have a permanently established encrypted VPN tunnel between those sites. Why? Because it's a whole lot cheaper to buy an internet connection in Atlanta and Arizona than actually get a direct connection through a service provider between those two sites. And they are accurate. That is another kind. That is a site-to-site VPN. But where a lot of people you say, okay, well, what if I take my office in Arizona and buy a T1 line? Which, by the way, is not 100% accurate, because T1 is just a measure of speed. You could have a T1 internet connection, a T1 DSL line, a T1, it just equals 1.544 megabits per second. But again, you poll those 40 of 50 people, and most people will tell you, well, a T1 line is actually a dedicated link between you, and let's just say this is the California office, right? So I buy a T1 line. That's not a VPN. Actually, it is. It is a virtual private network. Now, it's not going over the internet. You may not be using encryption over that T1 line because it's perceived private, but remember, it is a virtual private network because you are going through some service provider. It's Sprint, it's AT&T, it's Cox Cable, it's CenturyLink, it's whoever, and we are assuming Again, that there's no ill-willed person at that organization capturing your data and selling it to your competitors or something like that. It is a virtual private network. You have chosen to trust whatever carrier is delivering that T1 to you, and that's another type of VPN. The only way you get away from the V in the VPN is literally to grab your shovel and trench a cable from Arizona to California and bury that line and say, it's my line, no one else will use that. Then it's I guess it would just be a PN, not virtual, it'd just be a private network between your sites. So I define that because you'll see as Amazon starts talking about VPN connections, there's many different kind of ways that's being used. Let's explore it. In the AWS world, they allow you to establish a VPC, virtual private cloud, where you define the master subnet and all the little subnets for your availability zones. And within the VPC, you have the ability to create a VPN. This is where the feature exists. The most common type of VPN that you can create is called a hardware VPN. So where you establish a permanent VPN connection, that tunnel, from your office into the AWS cloud. It's the equivalent to the site-to-site VPN that I gave you. And this device can be a Cisco router or firewall, Juniper, or it could be a SonicWall, whatever kind of device you have that runs your network. Now, this, out of the box, at least from the AWS side, is redundant. They automatically, when you click the option that I want a VPN connection, they automatically give you two distinct endpoints, two distinct public IP addresses that you can establish a VPN connection to. Now, your side, most of the time, and I'll say today, most of the time, is not redundant. You have a single internet connection, making this called a single VPN. Which means if you lose your connection, you lose the entire VPN. Now, it's becoming more and more common for businesses to add a second router with a second backup internet connection. And you can establish, there's multiple ways you can do this. You could establish two VPN connections from each device to these two devices. So if something on the Amazon side went down or something on your side went down, it was completely redundant. That is totally fantastic, and that's the way to go. But as I'm talking about this, I'm like, hang on, whoa, why would you do this? Good question. Why would I have a VPN connection from my office to the AWS cloud? Well, a couple reasons. One, it allows you to establish connections to your servers outside of it, or essentially past the internet firewall of AWS. I'm not assigning public IP addresses that are available to the whole world, or trying to say, okay, well, only connections coming from my public IP address that could change can access, all these different resources on the AWS side. A VPN just lets you have private network to private network communication, kind of full communication between your devices. Now, you can, with security groups, put up firewalls at these to even protect them from your private network, which is recommended just in case you get compromised in your private network. You don't just expose your AWS servers to attacks and things like that as well. But it's that true private to private connectivity. Let me tell you where I think this is going. This is big. It's kind of where I think the world is going. High-speed internet connections are becoming more and more common. I believe, right now I'm at the end of 2014. By the time we get to 2018, 19, 20 at latest, it's going to be commonplace for people to say, "Oh yeah, I got a gigabit connection to the internet. Oh, I got a 10 gig internet connection." Is going to be one of those things that you hear. I know it sounds kind of crazy right now, but really not really crazy anymore. And when you get to that point, you have to start saying, "Well, you know what? With that kind of speed, we could run our entire server infrastructure." I'm talking what would typically be internal servers at your office. I could actually run those from the AWS cloud. Whoa. You hear what I'm saying? That's a game changer, right? Your entire internal, external, everything infrastructure could be sitting in multiple availability zones in the AWS cloud, and all your offices connecting to there over VPNs. Wow. That's one option. Second option, and this is not one provided by AWS, but a lot of people do that. What about those people running around with their tablets? That little first option I was talking about yesterday, the remote access VPN. If you want a remote access VPN, you're going to have to set it up yourself. And what I mean by that is you would actually establish a server that runs software VPN client within one of these availability zones. It could be Windows, it could be Linux, whatever. They both have their own little remote access flavor, and then you could use a VPN client, whatever client you have installed on that device, to VPN here, and then this would provide access to the devices in that availability zone, or even others, to where based on your firewall settings between availability zones, you could access whatever you want over a remote access VPN, but that is not provided by AWS. What is another option that is provided by AWS is called Direct Connect. And this is cool. This is where Amazon has partnered together. Actually, can I show you something? In an extremely rare presentation, James Hamilton, one of the engineers at AWS, did a tour of an AWS data center. So I know it's kind of like, oh, really? Seriously? These invisible data centers all over the world? We can see what one looks like? Absolutely. You can actually see it in the background right here. This is what an AWS data center looks like. Take a look at this. As I drop down a little bit more, they're showing how they build their data center systems, blah, 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 pace of innovations. Look, hang on, let me find this picture I'm thinking of. Look at this. That's it. Right there. I know, not what you may think of, but that is one of the AWS data centers. It's a modular design. So when we're talking about an availability zone, that's actually what one of the availability zones would be. Is this modular design, redundant power? Tell me this night picture. You're just waiting to see like Tom Cruise hanging from some wires over here, like, you know, tapping his way into this data center through one of those vents or something. I don't know. But anyway, this is one of the AWS data centers. You know, they show all the power, all that kind of stuff. But anyway, what they do with Direct Connect is essentially have fiber optics. So here's that little modular design. This is an availability zone. Right there. And they have direct connections to outside data centers that allow consumer access. Again, nobody or very few people know where the AWS data centers are at, but there's all kinds of data centers where people will let you co-locate devices in it. So one of the big drawbacks originally with AWS is, oh man, you know, this is great, but I don't want to pay, you know, X number of dollars or cents per gigabyte of storage because I have terabytes and petabytes of storage, which would be extremely cost prohibitive to put in the AWS world. I just want to be able to put in my own storage, if I can talk. I want to put my own storage in a data center that's connected into AWS, and they let you do that through Direct Connect. There's all kinds of data centers that allow you to come co-locate your equipment there, and then you get fiber lines straight into an AWS availability zone. Pretty cool, right? Now, they also have Direct Connect plus VPN. You'll see it described on the VPN descriptions, where you can then get a private line if you want to, or connect site-to-site VPNs, but most of the time it's going to be a private line. Maybe you get a 1 gigabit per second fiber connection coming into this data center. I mean, AWS doesn't allow you to come directly in, but this is one of their partner data centers, and you can get a Direct Connect fiber line into there, essentially giving you direct fiber into one of the AWS data centers, to where now, again, you go back to that wild vision I had, to where nobody's running on-site servers anymore, because why would you? You've got everything spun up in an AWS data center and gigabit connectivity over to that. That is called Direct Connect to plus VPN. That's why I had to redefine VPN, is even though that might be going through a private carrier, to get that, I mean, you could tie directly into, you know, there via, let's just say, Sprint or something like that, and you've got that private carrier in. This is still considered a VPN connection, virtually private. You're just going through a bunch of private entities to get there. Last thing I want to say, and then we'll get into the configuration of all this, is your options for routing when you bring up your VPN, whether it be Direct Connect, site-to-site, whatever you've got. You've got two options for routing. One of them is static. The other is BGP. So this allows you to either statically type in, and this is where you'll go into your VPC routing table and you'll say, okay, to reach the 172.30.100 network, use the VPN connection. That's a static route. Manually, an administrator typed it in. And on this side, you put up your static routing and say, okay, to reach this availability zone, 172.16.1 and .2 and .3 and et cetera, I'm going to put static routes into my device on this side so it knows how to reach. Well, as you grow and your LAN turns into VLANs and multiple offices and many availability zones with many subnets and all that kind of stuff, it becomes very cumbersome to statically keep typing those in. Thus, BGP. The border gateway protocol allows you to establish a dynamic routing relationship between your device and AWS, to where as you create availability zones, they can automatically replicate their subnets. I shouldn't say replicate. They can all automatically advertise their subnets to your device, and vice versa. Your device can advertise all your subnets to them. Which is more popular? By far, static routing. It's a more well-known technology that more administrators know. It's widely supported. Every kind of router and firewall will support that. Whereas BGP, you've got to get some pretty high-grade equipment to do it. I'm actually going to give you a couple tips on that as we go. So let's do this. Let's get started. I'm going to go into AWS, and we're going to configure, exactly this environment that you can see right here, right before your eyes. That sounded like a magician just then. Watch this. Wait, no, look over there. So this is Amazon Web Service. I'm going to shoot straight into VPC. Now, VPC, if I click on it correctly, is not configured at all right now, which is going to give us a great build it from the ground up feel. You'll love this. So I'm going to click on your VPC. We'll name this AWS World. 172.16.0.0. Again, this is the master subnet that I'm going to create. I just, by the way, looked at tenancy, and I said, I wonder what dedicated costs nowadays. It's actually extra $2 per hour to have dedicated hardware of one server that belongs to you, which you can imagine adds up pretty quick, being $48 a day, right? Am I doing that math right? Yeah. So AWS World has been created. I'm going to go to my subnets, click Create Subnets. Let's get our two subnets. We'll call this Subnet 1. AWS World, we'll throw it in East 1A, 172.16.1.0/24. And then we'll go in and add subnet number 2. Actually, you know what? I'm just going to create one subnet to do the VPN connection. You can create as many as you want down the road, but this will demonstrate the concept. We need an internet connection for our lovely subnet, so we'll just call this My Internet. Create. So I've added a internet gateway. I'm going to attach that to my VPC, so now the devices in there can reach the internet. I need to add a routing table. So let's go in and add a routing table. There's the default one that comes with the subnet. I always create my own, so we'll just call this My Routing. And it'll be for AWS World. Yes, create. Then I'm going to go into this routing table. Number 1, create the internet route. So click on Routes. Edit, and we'll say to reach the internet, if you're using this routing table, I'm going to go out internet gateway, blah, 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 the one that I just created. Click on Save. Now I'm going to associate that routing table with my subnet. So click on Edit, say that's the subnet 172.16.1, click on Save, and we are good. So now we've got the routing table created. I think we're ready to throw a server in there. Let's do it. We'll go to EC2. Get a instance running. We'll use a cheap Ubuntu server. Next, it's going to be in subnet number 1. Next. Let's create a new security group. Let's go ICMP and SSH from everywhere. ICMP and SSH. All right. So SSH is automatically added because it's an Ubuntu instant. We'll throw ICMP. Actually, let's just do all ICMP, a little easier. And we'll say from anywhere. And look good. Yeah. All right. Review and launch. Launch. Yes, I own those keys. Okay, so I'm launching the instance. It's now spinning up an instance into EC2. Now I'm going to shoot back over to VPC. I meant to say into my subnet in EC2. I'm going back to my VPC, and I'm actually not going to allocate an elastic IP. Normally, I would say, okay, let's throw a public IP address in here, but I'm going to create a completely private or VPN accessible instance that's here. That's just for my internal. It's an intranet server rather than reaching the internet. Okay, so now what? Okay, well, while we're waiting for that instance to spin up, I'm going to come down here to the VPN connections. I'm going to slow down. We've created the VPC environment. Now VPN. First thing I have is customer gateway. What is this? This is something that represents me on my side of the connection, or essentially you when you bring up your connection from your corporate office. So I'm going to click on Create Customer Gateway. It's going to say what is the name, so you essentially name it and give it the public IP address of your site. Now obviously it would be very beneficial for you to have a static IP address remotely, or you're going to be adjusting this thing all the time. So I'm going to call this My House. My house in the middle of the street. I'm going to go actually to 172.168.1. I have a Unify EdgeMax router, and I told you I was going to give you some tips. Oh my word, this router is amazing. So if you actually go to Ubiquity, this router, it's called an Edge Light router, beats Cisco, Juniper, like enterprise grade in terms of packet forwarding. It runs an operating system called Valletta, which if you Google that, V-Y-A-T-T-A, V-A-Y, it's something like that. So you type it, Google will correct you because we no longer know how to spell. Google fixes everything for us. So you type that, it's an open source operating system that actually is so robust and dynamic. This thing even supports BGP. It's under $100. Yes. I know you. What? Yeah, someone's coffee just spilled right there. I felt it. What? It's under $100 for this little edge router. Anyway, go check it out. These things are the bomb. I use it for my house. I use it for my business. I have them at my office. They're everywhere because they do everything, and they're under $100. Anyway, you can see right here is my public IP address. Again, I'm running this from my house right now, which has just a basic DSL connection, PPP over Ethernet. If I could highlight that, copy that to my clipboard. This is my public IP address. I'm going to paste that into, it didn't take. I'm going to paste that into the IP address field over there. Now, notice this is where if I wanted BGP routing, I could choose dynamic on there, but I'm just going to use the static routing from there. So this defines your router at the remote side. Now, Virtual Private Gateways defines the routers at the Amazon side. So I'm going to click on, actually, hang on, before I go any further. Yeah, this looks good. Okay. Click on Virtual Private Gateways, Create Private Gateway. I'll name this AWS House. You can see there's not really any configuration that you have in there because it automatically creates that. So I'm going to say AWS House, it's detached. Click Attach to VPC. Attach it to AWS World, my VPC environment. And what it's doing, it's going to take, it's going to take some time as we do this because it's actually spinning up dual redundant routers that are able to do VPN connections. So we got a lot churning right now. EC2 instance spinning up, virtual private gateway generated. Let me pause and wait till all that's done. There we go. It takes about 2 or 3 minutes to attach that virtual private gateway to the VPC. Now we can drop down to the Add VPN Connection. Okay. Right now it's blank. I'm going to click on Create, and in typical AWS style, they keep it so simple. If you've ever set up a site-to-site VPN before, you know how much work that is. There's the phase 1, phase 2 tunnel, encryption, hashing settings for both of them, pre-shared key or dynamic certificates. You have all kinds of complexity with that, but in the AWS world, not so. Here's how they do it. You type in the name of it, so I'm just going to call it My House VPN. Virtual Private Gateway, I link it to the gateway I just created on the Amazon side. Customer gateway, I'm going to the gateway that I just created for my side of the connection. Then I come down here and choose the routing option of static or dynamic. Now, it's going to say what is the static prefix or prefixes that you have on your side, and you can put a list in there. I'm going to say 172.30.100.0/24. In actuality, this is, my house doesn't quite look like that, but this is the diagram of my house connecting into the AWS cloud. So it looks exactly like this. So I've got my static IP prefixes. Click on Yes, Create. And there is rates, and I don't even want to go through them, but there is rates for the VPN connection. It says, hey, you're going to be charged as soon as you do this. And you can check what those are because, again, they're always changing. This step will also take about 2 minutes to create, and it takes a little bit longer because my side is actually not configured for the VPN as of yet. All right, it takes about another 2-3 minutes there. Now take a look at this. I've got the VPN, my house VPN, that is now established, at least from AWS perspective. I have the tunnel details. Remember I said that the AWS side is always redundant? This is why. I can see tunnel 1, tunnel 2. These are two distinct endpoints that are ready to accept the VPN connection. Both of them showing down because my side of the connection has not yet been established. I can see the static routes. You can see it's pending connection to 172.30.100. That's my house subnet on this side of the connection. So it's essentially just waiting. Now, those of you that have configured a VPN before are going, what do I do on my side? What are all the settings? Where is the complexity of a VPN? Take a look right above the VPN connection here. Download configuration. Essentially, what Amazon has done to simplify this is generate configurations for every major router/firewall platform that is out there in use in businesses, and gives you essentially the configuration to type into your side. I'm a Cisco guy by nature, so if I had an ASA or an ISR, that's the routers, I could just click on that and boom, they give you, here's the config to type in here. Let me show this. I click on yes, download. And I'm gonna, let's open this. Notepad does not like these text files because there's no line feed, so it just puts it all in one long line. So I'll use WordPad, and right here, let me just bring this into the view, is the configuration that I would type into my side. And essentially they're saying, hey, here's your VPN connection, here's your IKE phase 1 settings, you just paste that into your router, here's the pre-shared key and everything pre-configured for you. So it literally just becomes, I take this configuration that they gave me and copy and paste the whole thing together that assembles the VPN connection on my Cisco router side. Now, unfortunately, they do not have a configuration generator for my edge router. So what I can do is go to this generic, and what they do is just give you an explanation. They say, hey, here is an explanation of all of your settings. This is the name of your connections. Here is, in a kind of a table format, how we do security. Here's your pre-shared key. Here's what authentication algorithm. So instead of just having a copy and paste configuration that you put into your device, you assemble it manually either through a GUI or, you know, in my case, my little EdgeLight router has a command line interface through Vieta that I go in and configure it. So let me show you my side of the config. There it is. This is the command line configuration for Vieta. They don't have an option in the GUI as of yet to set up a VPN connection to AWS because AWS uses a little more complex VPN configuration than most. They actually establish a GRE tunnel, is what that's called, a generic route encapsulation, which allows you to run all communication to AWS, even stuff that's typically not allowed over a traditional, that's called IPsec VPN connection. So you have to go a little more command line, at least in this world. You might say, wow, how'd you figure out how to do that? Hours of Googling and piecing together and testing. This is the benefit you have with CBT Nuggets, is I go through hours of work and figuring all this out. I go, there's the config. Matter of fact, I'll make this configuration available for you if you want. If you happen to get a Ubiquity router like I have, this will give you a great AWS-based configuration for it. Okay, so I'm going to take this and literally just paste it right in. I'm going to bring up a connection to my router, open. There it is. They call it Edge OS admin. My password, configuration mode, and then I'm just going to go paste. So it's typing in all that configuration for it. Now, there is a couple things you can do from the command line, but I couldn't figure it out, so I do it through the GUI. So I'm going to come in here, go to my GUI, which is probably going to panic in just a moment. It's like, hey, you updated something behind the scenes. Yep, there it goes. Please refresh. So I'm going to come in here. There's a few things I have to add. One, I'm going to go into the NAT, and I'm going to say, do not NAT things to AWS. So we'll say source NAT, no NAT AWS. And we'll say outbound interface will be this guy. And we will say exclude from NAT, because essentially, normally this is what the router does, is NAT everything. 172, so I'm going to put my subnet in here, and the remote subnet in here, right there, and hit save. It normally NATs everything, but I'm going to say do not do network address translation for, okay, there we go, for stuff that is available over the AWS cloud, right? So that's the first piece I'm going to add. Second piece is I need to add that static route on my side. So I'm going to come up here to routing, click on static, and I'm going to say, hey, if you want to get to 172.16.1, We're going to use the next hop address of 169, and actually this comes straight from the configuration file. Where'd it go? Right there. It's saying use. There we go. Essentially, the Amazon side of the connection is 169.254.255.37. So I'm going to point my static route and say, to get there, use that as your next hop gateway. Distance, how good is that route? Really good. Click on save. Distance of 1 is the best you can get. So I'm going to click on save. I've now added my static route. So let's see. I've got the VPN. Click on IPsec set to site. It's all there. So it does do IPsec from the GUI. It just doesn't do the complexity level of AWS. And that should be it. Let's give it a try. Come over here to AWS. Let's figure out what the IP address is of the machine I just spun up. So here is my running Ubuntu machine. It is 172.16.1.220. So I'm going to open a command prompt on my side. Hold my breath and do ping 172.16.1.220. Oh, hang on. No. Okay. So let's figure out what's missing. Okay, so let's do some troubleshooting. There's a lot of pieces that go in. Okay, so we've got this just saying you've made some changes. Let's exit out of config mode. I'll do show VPN IPsec SA. State is down. Okay, let's look at the AWS side. Okay, so we've got VPC VPN Connections. Click on this guy. Look at the tunnel status. Down. Okay, so let's start troubleshooting. We've got my AWS house. It looks attached. Customer gateway has the right IP address in there, right? Let's just verify. Indeed, I have the right IP address. We've got that. We've got the routing on my side. So this going to this private IP address. Hang on, let's go back here. Let's do a show configuration. Let's do this config. Let's do show VPN. All right, so we've got AWS. All of this stuff was given to us. There's the tunnel going from this side to that side. It's using the tunnel 0. Let's do show interfaces. We've got PPBoE. There we go. There's my tunnel interface. So IM 169.254.255.38. I'm looking at the config. That 38. That is correct. Okay. So static route is there. I've got the NAT, which says exclude. Hang on. This guy to this guy. That is exclude no NAT. Okay, so that's good. Let's look at the AWS side. So we've got customer gateway VPN, VPN connection, static routes. Okay, so that's available. Ooh, hang on. My routing table. Has said send everything to the internet gateway. Hang on, let's edit this. Okay, so I didn't modify the routing table associated with the subnet. I did the VPN routing table, which is great, but essentially the subnet, the server in the subnet doesn't know when to send data to the VPN. So I'm going to say to get to that subnet. Look at that. Man, it's so easy to even with VPN connections are notoriously difficult, not because they're so complex, but there's just so many pieces, and you can see even in the AWS world, they're easy to forget a piece. Okay, come on now. 172.16.1.220. Okay, hang on. No, you must work. Hey, a VPN connection. So we've got summary. Let's just do a quick refresh. Customer gateway, tunnel details, still down. What am I missing? Okay, hang on one second. I think I figured it out. I got the wrong pre-shared key. When you download the generic config every single time, it gives you a new set of pre-shared keys. You can see this is Ike Tunnel 1 for the first set, and this one goes to, who does this go to? .164, which if I look at my config, I'm going to the VPN peer .162. Remember, you get 2 of them, so I'm going to this one, and I put the wrong. Well, at least I'm theorizing. I just saw it, and I'm like, I gotta bring it back and record it. So I put the wrong pre-shared key in. So let's try this. I'm gonna go in here. This is the pre-shared key for tunnel number 2. Come in here. Shoop. Replace it. Paste. I think I should just be able to go into the configuration. Well, matter of fact, let's do this. I'm just gonna. I got desperate. I rebooted. I did everything. I was like, "What's going on?" So hey, let's just reconnect again. Get this guy out of the mix. I'm gonna tear the whole thing down, and we'll do no VPN, or actually delete VPN, which deletes the configuration. Delete interfaces tunnels. Let's just do interfaces tunnel. I'm going to paste this whole thing back in there again. There we go. Paste it in with the new and improved pre-shared key. Good. Commit. Get that guy up and running. I think it should keep the static routes that I have in there. Hang on, let's wait for this guy to refresh and see what happens. Let's verify. We've got, let's see, 172. We still got the static route in there. Good. And it should still have the NAT exemptions. So 172, that's right. Good. Good. All right, so dashboard. We've got 230. Whoa. Hang on. Whoa. Hold the phone here. 182. That's the right. I rebooted my router. It got a new IP address. Cursed dynamic IP addresses of home connections. Please hold. Well, that was painful. All the more emphasis on getting a static IP address for your site, because you can't actually go in and change the customer gateway side IP address without deleting the whole VPN connection. I created my new house with the new public IP address that I got when I rebooted my device. So that should now all be created. I'm going to come in, and I literally had to go through and change all the pre-shared keys, everything like that. I'm going to paste this in. And let's get I already have a continual ping going to 172.16.1.220. And let's do a commit and see if the VPN connection comes up at this point. See? It's not just perfect every time. Oh, there we go. In CBT Nuggets land as well as the real world. So that shows you how to create a VPN connection from site to site using the static built VPN. Now, at this point, without an elastic IP address, without anything else there, we've got full connectivity going into our device. And I should back up. One thing that's worth mentioning, even though it is a VPN connection, Amazon considers it a separate group. So if you want, you can come in here and set up your security groups. Right now I just have ICMP and SSH allowed from everywhere, but you can actually say I want to allow everything from a source of, and then your VPN subnet, so that the security group can match and allow you that full access to your servers in the AWS cloud. So we have seen the VPC connection options and design. We saw the hardware VPN, Direct Connect plus VPN, even the software-based VPN, so you can allow your remote access clients, and the somewhat smooth, somewhat bumpy configuration of an AWS VPC with a site-to-site hardware-based VPN. I hope this has been informative for you, and I'd like to thank you for viewing.